Okay, so in this lesson we're going to learn how to create the hashing for a BCAMapByHashedArrayList. So the idea is in your first lab, you had a single array list where all the map elements were stored. So now we're going to use hashing to spread them out across multiple array lists to trade space for speed. So again, a big thing in computer science is trading additional memory for additional speed. And so that's what we're going to be seeing today. So I'm going to be kind of coding this along with you. I'll be more or less copying and pasting the code so you can pause me and so you have time to type it in. Our member variable is going to be an array list of buckets. So the first time you just had a member variable that was an array list. Well, now we're going to have multiple array lists. So it's going to be an array of an array list of buckets. And so let's do a side video to kind of talk about what those buckets are. So let's talk about how these buckets work. So in the first time we did the hash map by array list, we just created a big array list, and we will put each of Sam, Grace, and Liz into that array list. And this data that I have here, Sam is 15 years old, Grace is 18 years old, and Liz is 16. So the age will be the value, the name will be the key. And the hash is going to be if we hash the name. These are just made up values, I just invented. If we hash the name into a number. So Sam hashes into 57, Grace hashes into 23, and so forth. So again, with a map by array list, we just created a single array list, and Sam, Grace, and Liz would all be in that one array list. When we start doing a hashed map, so we're BCAMapByHashedArrayList, the idea is we're going to create a bunch of buckets. So we're going to create an array with an arbitrary number of buckets. For now, we'll just make it 5 so we can actually draw it. But in reality, it would typically have 100 or 200 or 500. Again, we want to get a ratio where there's more buckets than there are elements. So given that we have 3 elements, 5 buckets is actually pretty good. 4 or 5 buckets would be fine. And then each of these has their own array list. So an array list, let's draw this completely on the bottom one. An array list is an object. Inside here it has size, and then it has an array, right? That's what an array list is. And then by default, the array list has 5 elements in it. So our BCA array list creates a 5-element empty array at the beginning. So each of these is going to do the same. So I'll just put a small box here. That means size and array. And then this thing has an array coming off of it, right? So we are trading. We're going to use a lot more memory, but it's not terrible. We're going to use a lot more memory to set this up. So tell you what, we'll draw all these all in. We're going to run out of space pretty fast when we try to put in the entries, but we'll figure it out. So at this point, we have 5 array lists. So we have an array of array lists. The thing on the left I call the buckets. So this here we call the buckets. And so we're going to hash into a bucket, and that puts us into an array list. So let's put Sam in first. So Sam hashes to 57. Well, I have 5 buckets here. So I'm going to do 57 modulus 5, which means 2. So if we think of our buckets as 0, 1, 2, 3, 4, he's going to go into bucket 2. So Sam, I'll just write Sam here. We'll end up creating an entry object over here like we did before, but Sam is going to end up in this first array position. When we put in Grace, Grace has 23. 23 modulus 5 is going to be 3. So Grace goes into a different bucket. So Grace, I'll just put G. Grace is going to go here. So the beauty is that Grace and Sam are in arrays of length 1, essentially. This extra space to the right we don't worry about. That's not really part of the list at this point. It's just extra space that we mallocked, that we created. Now finally, Liz. Liz is 42. That's also 2. So this is what's called a collision, because both Liz and Sam ended up in the same bucket. So at this point, Liz will be here, and she will just be the second position in the list. So in this simple example, we ended up with 1 collision. We have a bunch of lists that are size 0, and 1 list that's size 1. Ideally, if the hashing works out nicely and it's nicely randomized, we really won't have that many collisions. And so having this list of size 2 or a list of size 3 is going to be unusual. Most of them will end up being, like Grace, a list of size 1. So that's what we're going to be doing with our coding, and that's the concept of the buckets. Okay, so now that we kind of understand the concept of the buckets, let's do, so this is going to be an error up here for now just because we haven't implemented all the methods. We'll put them in eventually. Let's go ahead and do getter default. So I will put in the beginning of it and we'll just kind of talk it through. So getter default, remember, we'll look to see if the key is currently in the dictionary, in the map. If it is, it'll return it. If it doesn't, it'll return the default value. The key cannot be null, so we should be throwing an exception. That should be in your first array list already. So here comes the interesting part. Now we need to figure out what bucket this key actually is in. And so we're going to do some hashing. Maybe I'll type it the first time so I can talk about it. So I want to figure out the bucket number. And so the first thing we're going to do is do key.hashcode. So again, our key is a string, and strings in Java already have hashing built in. So this will get us a number. Now we want to bring it into the positive number space. So we're going to do math.abs. And so now it'll bring us into the positive number space. And then once we've done that, then I want to just bring it into the length of buckets. So I'm going to do a modulus, buckets.length. You could do the modulus first and then the abs, but you'll get a different answer. So you just want to be consistent on how you do it. So that tells us what bucket we're dealing with. So now let's go get that bucket. So we'll just do BCAArrayList, list equals buckets, and it'll do bucket. Now the interesting thing now is now the code that continues from here on down is actually going to look very much like your original lab. Because at this point we have a single BCAArrayList that we're putting this key value pair into. So now we're going to walk down the array list. And if we see that it equals at any point, so we're going to go down every element of the array, we'll cast it to a BCA entry, and then we'll compare the keys, and if any of the keys are equal, then we found it, so then we'll return the value. If we don't ever find it, then we'll just return the default value. So this second part, actually most of this should look like the lab that you did for me, except for this part in the middle. Everything else actually should be pretty similar. So what do we want? Let's do put. So put is going to be pretty similar. So for put, again, we're going to make sure key and value cannot be null, just to make sure we stay out of trouble. Again, we're going to just figure out, hey, what bucket is this put going into? Right, so that's basically the same code as we had up above. We could create a sub method like getBucket and passing in a key. That might be ideal. And then we're just going to go down the list and to see if it's already there. And if it is there, we'll replace the value and then return the value. Right, so we're going to go down the list, see if it's there. If we ever find it, store the old value, replace the value, and then return the old value. Otherwise, add it in. Again, this is going to be very similar to your lab, so if you had trouble in the lab, you could always kind of peek back at what you did and edit your previous code. And if it's not in there, we're going to create one and add it to the list. And then we'll return null because there wasn't anything there before. So let's continue on with remove. So remove, again, the same thing again. We're going to make sure that the key is not null, and we'll get the bucket. And then we're going to go down through and look for it. So we'll do a for loop again that goes through the list that we're in. And again, it's the same code again, checking to see if a key matches. If we find it, we'll store the object to the side. We'll call list.remove at that position. This way, if we do by key, then I'll have to do comparisons again. So it's better to do position, because it'll just go there and remove it, and it'll do the shift. And then you can return the object though. If it wasn't there, we're going to return null. So then we can put in our return null. Let's do clear. So clear, we're going to need to go through the whole map. and basically clear everything out. So basically we're going to tell every bucket to clear itself. So this is kind of delegation. We need to go through a list of buckets, that's an array. And then for each array element, which is a BCAArrayList, tell it to clear itself. And so it knows how to clear itself, and it'll go ahead and do that. Now isEmpty is kind of an interesting one. We're empty if all the array lists are empty. So we need to go through all the array lists and check if they're empty. If every single one is empty, then we're empty. If any of them is not empty, then we're not empty. So here goes. Here's isEmpty. So isEmpty, go through the entire array. For every single array list, check if it's empty. It's complaining that I wrote it like this. Okay, so let's do it the way IntelliJ would prefer. It doesn't like the equals false. So if I say not is empty, return false. So basically, if anyone is not empty, then the whole thing is not empty. If I get through the whole list without finding it empty, I can return true. Okay, next one. Size. So we're not keeping track of size for the array. The size for the map. So the size is basically the sum of the sizes of the independent array lists. We could cache size, but we're not going to call it that frequently, so there's no reason to really cache it. By the way, it's probably complaining it would prefer me to write a for each loop here. Feel free to change it to a for each loop. I'm not really using the index, so this would be a fine place for each loop. So size, basically again, the code looks very much like isEmpty. I'm going to go through every array element, so we're going to go through each array list, get the size of that array list, add it to running size, and then return size. Okay, let's talk about toArray. So toArray is going to be similar to what you did before, but now we need to go through all of the different independent BCA array lists. So we're going to need to go through the array of array lists and append each of them on individually. So let's get it set up. So toArray, first thing you need to do is create the array that I'm going to return. So previously you would have just said ArrayList.size because the array list had the size of the number of elements. Well, now I need to go through all the elements, so I'll call this thing, which will run through all the buckets again to get their sizes. And so now I know how big my return array needs to be. I'm going to use index to index into array entry list. And this is where I'm going to be storing things. Now let's loop through all the buckets. And then for every bucket, loop through all of its content. So it's going to be a nested loop. Okay, so we'll have a double nested loop. The outer loop is going down the buckets. The inner loop is going down the lists within the buckets. So we'll get each entry, from get the bucket, get the element in the list. And then we're going to take that, we'll create a new copy of the BCA entry. And then add it to the entry list using index. So this way index is independent of I and J. Once this double nested for loop finishes, we can return the entry list. Again, pause me periodically because I'm sure this is going way too fast to type, and that is fine. Keys. Let's talk about keys. Keys looks like almost the exact same code, except when we append in, we're not going to be appending in BCA entries, we're going to be appending in strings. So here's the starter code. Again, this looks very much the same. We're going to create an array of strings rather than an array of BCA entries, but still it needs to be size of whatever the map is. We will then have a double nested loop. So we'll have the same double nested loop. Here, instead of making new copies of BCA entry, we will just kind of copy over the key. Now, a question came up in Discord, so it's good to talk about it here. I'm not doing a deep copy of the key. I'm just copying the reference. But since keys are immutable, this will just get copied if I then change that string later. So that's fine. And actually, well, we'll talk about values when we get there. And then we'll just return the keys. Values is basically the exact same thing again. So I will copy the whole thing at once this time. So for values, again, now it's going to be an object array rather than a string array. Here again, I'm just going to assign a reference of the value to the values to the new array. I'm not going to make a copy of the object. This is how the values method for the Java util map works. It just copies the reference rather than doing a deep copy, so that's why I did it here. But otherwise, the code here is basically the same thing as for keys. We have one or two more, so let's take a look at what we have left. So we have get. This will probably be the same as what you implemented. If this is not what you implemented in your lab, you might want to go back and change it. Get can just call getter default and pass a null in. Let's do contains key. So contains key, it just returns true or false if the key is in here. So again, we can call getter default. There's no reason for us to recode it. We can just call getter default, pass in default value of null. If this doesn't return null, then it contains key. Otherwise, it doesn't. So we can just basically keep reusing get or default. Let's talk about contains value. So this is where we need to go through the whole list again and to see if the value is in there. So again, we're going to make sure that they don't give us a null value, because that'll cause us a null pointer exception at some point, so we want to be careful of that. So we're going to go through every bucket and then go down the list of each of those buckets. So this is actually very similar code to what we just did up here for keys or values. I wrote it slightly differently, but not much differently. So we're going to go down the list of buckets, and then we'll just get the bucket and put it into a list variable. So I created an intermediate variable. Again, this could be a for each loop, so I could avoid the whole I thingy. And then we'll go through J. So we're going to go through all the elements of the list. And then we're just going to do a comparison for each value. And if we ever find it, we'll return true. So this is a very standard index of, but now it has a double nested loop rather than a single nested loop. If anywhere as a result of these for loops we find it, we'll return true. If we ever reach the bottom, return false. That means this value is nowhere in the map. And the last thing we didn't do is our constructor. So let's talk about the constructor. The constructor, we need to create the buckets array. Right? This whole time we've been talking about the buckets array, but we've never actually created it. So let's create it now. So our constructor is going to take a number of buckets. So the idea is that we want to create an appropriate number of buckets for our data set. And Java util HashMap will auto size itself as you add things in. I'm sure you can give a default parameter to start it at something. But we're not going to do any auto resizing. So we're going to set the number of buckets at creation time. And so we'll let the client, whoever is using this map, decide how many buckets they want. So that buckets will basically determine the array size, the length of the buckets array. So we're just going to create a number of array lists and put it into the buckets array. Now we need to initialize each of those bucket elements. At this point, we just have null references to buckets to array lists. So we'll go through the bucket list. So we'll go 0 to the end of it, and we'll instantiate a BCA array list and assign it to a bucket. Because when we create the array, all the references are null, right? This doesn't actually create an array list. It creates spaces for array lists, creates spaces for the references to the array list. We actually need to go through and instantiate all the array lists. And so that's your constructor. At this point, this is done. We don't see any more errors here. Let's flip over to the tester and add the code in there to make sure it works. So I've opened up BCAMapTest, and I changed the main to be calling BCAMapByHashedArrayList. You could also just add in the additional one here, but I just changed it over. I put in 10 buckets. You could put any arbitrary number in there. And then go ahead and run it and make sure everything passes. In my case, it did. If it doesn't pass, go back and make any corrections. And then let's jump over to word count. So if you remember word count, we did a baseline, which gave us the speed of the Java util implementation. And then we test our BCAMapByArrayList. If you haven't done that yet, add that in and test it and get your speed. And then let's look at hashing. So I created 5 more tests here. So we can test it with all different numbers of buckets. So one bucket should essentially be the same thing as BCAMapByArrayList, though there's some hashing that's going on, so it actually might be a little bit slower. And then there's 10 buckets, so basically every list should be 1/10 the length of the original list. And I did 100, 1,000, and 10,000. So I'll be curious to see, we could try 100,000 as well. Try any numbers you want. The idea is, let's see how the performance changes as we increase the number of buckets. So go ahead and run that. Okay, so mine finished running. And one of these things about these tests, there's a lot of gray factor. You'd probably need to run these tests 100 times and then average the results, because last time I ran this, it took 19 seconds, now it took 11. There's going to be a lot of wiggle room plus or minus, so you're going to want to run these tests a lot to really see what the true factors are in your machine. But again, the baseline took about 1/10 of a second, and then I was in the tens of seconds, say, for a BCAMapByHashedArrayList. With one bucket, it's saying it's 9 seconds. I'm going to say that this is about the same time. If I ran the test multiple times, I think that they would be about the same, that this one might even be a smidge longer. So it surprised me that's a little shorter, but that's okay. If we put in 10 buckets, notice all of a sudden we go from 9 seconds down to sub 1 second. So even whatever this number should be, this is probably a factor of 10 faster already, and that kind of makes sense with 10 buckets. And then if we go to 100 buckets, we're going from like 0.6 down to 0.1. So we're down to about the 1/10 range. If we go up to 1,000 buckets, now we can run our whole program in under 1/10 of a second. And going to 10,000, so we use 10 times more memory between these two, and we only pick up 2/100ths of a second. So at this point, it really might not be an advantageous trade-off, but going from even 100 to 1,000, that is a huge speed difference. So that really might be something that we're looking for. So I'm saying huge is 300ths of a second, so maybe the 10 to 100, you would need to pick your application how much faster it needs to be. Now again, if we look at the default implementation, it's 0.126, so we're beating that speed because we're really jamming in a lot of memory here. You could probably tell the baseline that I want to create a lot of buckets off rather than letting it figure it out, and you might get the same performance. So feel free to play with that. But there's your introduction to how hash maps work. We're going to still play with this a little bit more, because right now we're resolving collisions with array lists, which is typical, but they chew up extra memory. You can actually do the collisions with linked lists, which have advantages because they don't use up space when they're empty, or they use very little space when they're empty. So we're going to talk about that in our next lesson. So good luck typing this all in. I know this a lot, and we'll talk more.